In the first video of Bochka Techno tutorial series, we have been using FL Studio to create a distorted kick drum. I've been already asked, Marcin, are you going to make a similar tutorial but for Ableton users? I'm going to do such a video in the future, but for now I think that there are so many different kick drum tutorials for Ableton that I would like to show you how to do in that DAW something different. Aside from the kick drum and the percussion, you need in a Bochka track some atmospheric sounds that, aside from the leads, support the kick drum and the percussion. So in today's video I'm going to show you how to create a simple synthesizer sound inside of Serum from scratch, how to transform a snare drum sample into an atmospheric pad sound using a PaulStretch program. We will also play around with low pass and high pass filters and parallel processing to create a full atmosphere for your track. If you are looking for more hard/industrial techno sounds and Serum presets, check out my sample packs website where I sell, for example, my hard techno reinforcement volume 1 sample and Serum preset pack. This project from today's tutorial, you can download it free from my website. If you are looking for more Ableton hard techno projects, you can find them on my Patreon page, where you can also send me your track for a feedback. Now let's get into Ableton for a quick sound design crash course. I want to start by creating the most important sound out of what we are going to create today. And for me that sound is the synthesizer. So let's load Serum onto the new channel. And even with the default initial preset, we can already think of a pattern that we can play. I have already created my simple repetitive pattern here. I'm playing a single note because I don't want my track to sound melodic. So this simple pattern with the kick drum is going to sound like that. And now our job is to create a more interesting sound in place of that sort of wave. Serum is a wavetable synthesizer that has hundreds of different waveforms, out of which you can create many interesting sounds, but I will tell you something, 80% of the sounds you can hear in techno, industrial techno, hard techno, these are created by using the most fundamental waveforms you can find in the basic shapes wavetable, and we are going to stick with that wavetable. And inside of that basic shapes wavetable, we are going to use one of the most versatile waveforms available, that is the sawtooth wave. Sawtooth wave is a foundation of many synthesizers, including a famous screech sound you can hear now in every hard or industrial techno production. We have been already talking a bit about screech lead sounds in one of my tutorials that I made over a year ago, so here's a quick recap. To transform our saw lead into something more interesting, we need to use the unison section. A unison section is a place in the oscillator where I can play more than a single sawtooth wave instead of a single one, and each of these sawtooth waves is going to have a slightly different pitch, and that difference in pitch is adjusted with the detune. And what's cool about the unison section is that these detune unisono voices are automatically panned a bit to the left, to the right. This gives immediate stereo width. It's easy to hear that the more detune we use, the more chaotic the sound becomes. This is what we are going to capitalize on. On top of the amount of detune added, I can also control the volume of all detuned unison voices. This tells the width of the synthesizer. In the end, the unison parameter itself, the more unison voices we add, the smoother the sound should become. Because I've said that I want my lead sound to be quite simple, I will be using only a single oscillator. If I want to make a single oscillator sound quite interesting, I want to use quite a lot of unison detune now. And with that simple unison detune, the sound gets more interesting. Let's play this again with the kick drum. But for now we can hear that this lead sound is way too dry. We need to make it sound more smooth. Of course, the most obvious thing to make a synthesizer sound more smooth is to add reverb, but before adding the reverb I want to include one more effect that will help add some more modulation and background to the sound. So aside from that reverb, that I will turn off right now, if I want to make the lead more modulated, more smooth, the great choices are the hyper dimension effect and the chorus that I'm going to use now. It works just a bit similar to the unison section and the oscillator tab. To be more precise, a chorus duplicates the signal and delays it by a few milliseconds with an additional delay time modulation. From practical point of view, this effect also modulates the sound, making it more smooth. We will start adjusting the chorus, starting with the most important or maybe significant impactful parameters. This could include definitely the feedback. So the feedback is the function that routes some of the output of the chorus back into its input. And also the depth of the modulation will play a big part. And you can hear that this already fills a bit the background, just a bit like the reverb. To make that background sound simpler, as if it had less modulation, now I can use the depth knob. But I've mentioned earlier, my synthesizer has to be simple. I want to use as few effects as possible, so to make that sound interesting, I'm going to use quite a lot of depth to make that background more interesting. The background will be also modulated heavily by the rate knob. That tells the speed of the modulation you can hear in the background. In most cases, the rate knob has to be set quite low to avoid making the background sound too chaotic. Of course, that chaos is also dependent on the depth, but since I have left the depth on a quite high value, on the contrary, I have to keep the rate low. The chorus signal can be filtered in two ways. This is something that I can adjust with this far right knob. By default, this signal, the wet signal of the chorus, is low passed. Depending on your creative preferences, we can also use a high-pass filter instead of a low-pass one. Just click the label under the knob. Well, regardless of the type of filter we have chosen, the synthesizer seemed to be most interesting when all of the frequencies from the chorus wet signal has been passed through. The knobs that give the least influence over the sound of the chorus are the delay 1 and delay 2 knobs. Remember when I told you how the chorus works? The chorus duplicates the signal and these copies are delayed in time, plus the delay time is modulated as if you used an LFO on it. Delay 1 and delay 2 knobs can also, on top of that delay time modulation, add a delay time offset that is a fixed value. From practical point of view, this often doesn't change the sound by much. These knobs of course work, but they require a specific set of settings, for example, a small depth and a large feedback. In the end, what is left is to mix the chorus with the lead synthesizer. The chorus already helped making the synthesizer sound not dry. Now the next step is to add the reverb. And probably most of you are going to be far more familiar with the reverb effect. At first, to hear better what do these knobs do inside of the effect, I will turn up the mix back to 50%, so the reverb effect will be more emphasized. At first I like to choose the type of the reverb The plate reverb tends to be a bit more metallic and resonating, while the hall reverb sounds way smoother and natural. When it comes to lead synthesizers, most of the times a hall reverb is used because of its transparency, but this time I want the reverb to be a bit more original, so I'm picking the plate reverb type. And then, the most important control in my opinion is the size that tells the dimensions of a virtual room in which the sound is played. That's the theoretical description, but from a practical point of view, with smaller size values, we can make this reverb sound even more resonating and metallic. While the large size values give a more open and spacious reverb, unfortunately the size here is tied to the reverb's length, so if we want to make this reverb quite long, we have to agree with the fact that it's not going to be that resonating. What is cool is that since I have already used the chorus effect, now I don't need to use that much of a reverb, so the reverb doesn't have to be that huge and powerful. Because our lead synthesizer consists of a simple pattern, we can imagine that if we shift a bit the reverb in time as if we delayed it, the rhythm here could be more interesting, because imagine that the note in the synthesizer ends here, but the reverb starts to play somewhere here. To create that kind of effect, I can use now the pre-delay knob. And for example, I can keep the pre-delay set to around 60 milliseconds. The high and low frequencies from that reverb signal can be removed using, respectively, high cut and low cut knobs. But similarly to the chorus signal, I want the synthesizer to be quite full, meaning that there is no need for me to filter out either low or high frequencies from the reverb signal itself, so I'm going to use just a little bit of these high cut and low cut knobs. What often creates confusion is the damp knob. Damp knob also controls the amount of high frequencies in the reverb, but this works a bit like an automated low pass filter. Again, if I play a single note from the keyboard, this will be easier to understand. With the damp turned all the way to the 0, you can hear the high frequencies across all the reverb lengths. But if we start to use that damp knob, you can hear the high frequencies roll off after some time. Since the damp knob also has some influence over the amount of high frequencies, and we want our lead sound to be bright to be full, the damp knob will be also set fairly low. The last control is the width knob. That is quite self-explanatory. It tells the stereo width of the reverb added. And you can set up the width knob however you like. In the end, let's adjust the volume of the reverb in relation to the dry synthesizer. Let's also look at the volume envelope section that controls the volume of the whole synthesizer. If I turn off all the effects and play the synthesizer again, we have a very sharp and aggressive rhythm because the sound starts to play immediately and the sound also fades out immediately. To change that, I can use respectively the attack and the release knobs to create some fade in and fade out for the synthesizer. While I want the synthesizer to begin immediately, so there's little to no fade in, I could make use of a bit of an fade out that would complement the reverb I'm going to add back now. And by adding back the chorus effect as well, our synthesizer is finished. Even with such simple synthesizer sounds, you might want to spend a few minutes tweaking the synthesizer parameters to make the synthesizer fit your preferences better. In the end, I adjusted my synthesizer to sound like that. My final synthesizer preset is going to sound smooth because of 12 unison voices added, and without the chorus and the reverb, the sound sounds like that. And here comes a surprise, because even without any high-pass filter added, somehow my synthesizer lead sounds lighter than what we have heard before. The trick lies in the oscillator window itself. If I click the pencil icon near the waveform view, I'm going to open the oscillator edit window. And inside of that wavetable edit window, we will be interested in just the top section that tells the volume of each harmonic that builds the sawtooth wave. What do I mean by that? In simplest words, if I look at my synthesizer through the Voxenko span, I will see that my synthesizer is built out of many picks. Each of that pick can be called a harmonic, and the volume of each harmonic in the wavetable I'm playing through Serum can be controlled by simply increasing the volume of these pillars. I've been using this wavetable editor only to bring down the volume of the first fundamental harmonic and the second one to make that synthesizer sound lighter, as if I used a high-pass filter. Let's play our finished light Serum preset along with the kick drum we have made last week in FL Studio. You might think that the synthesizer is a bit too upfront in the mix, so now I'm going to also add the utility that decreases the volume of the synthesizer a bit, and the second utility decreases the stereo width of the synthesizer. Adjusting the volume of a sound and its stereo width are two different things that influence how much present any instrument is in your track. If you want to learn more about why I am separately adjusting the volume and stereo widths of a sound, please watch this video from my Basic Mixing Mistakes series, where I explain the confusion between the volume levels and stereo widths in context of a stereo mix of the track. And that will be the only synthesizer sound we create in today's tutorial, a simple yet effective lead sound. If you would like to learn more about sound design or other music production subjects, if you like the way I explain things, please head to my drillmusic.com website to learn more about my private music production lessons, where I can teach you in both Ableton and FL Studio. Free consultations are available as well, so use the online calendar to schedule your meeting where you will learn what you should learn to bring your music production to the next level. Okay, I have just realized that I was bragging about how full my finished synthesizer is. I forgot to turn on the chorus and the reverb effects. And this is our fundamental sound for the Bochka atmosphere. The next sound I want to create on top of the kick drum and the synthesizer is going to be a simple filtered noise sound. And as you will see in a second, using noise in your beat is a very easy way and a quick one to fill the beat with more mid-frequencies. When it comes to using the noise in our beat, of course, we will not want to use the oscillator A, but a noise oscillator instead. In the MIDI clip that I create now, I want to play just a single sustained note. And our first and most important choice is the noise sample that we will use to fill the mid-frequencies. Typically, I'm using the analog category that has more than enough types of different noise. But if this is not enough for you, I can also check out the last SOR category, and some of these Atmos sounds are also going to remind the noise. I want to add the synthesizer in the background, I can turn down its volume temporarily, and then it's easier for me to see what kind of noise is going to fit better. And apart from the type of the noise, what influences the sound a lot is the pitch of the noise itself. That makes the second thing to adjust. Because I mentioned I want to fill more mid and low mid frequencies with the noise, it would be wise to turn the pitch a bit down. If you are thinking when will be a moment when Marcin will add some distortion to the sound, I will tell you that now it's the moment to add some spice to the whole atmospheric sound. The synthesizer we added, we wanted it to be quite smooth, so we added some chorus and the reverb, but now, in contrast, I want the noise to be a bit more aggressive. For that, distortion is a great choice. But does it mean I have to head immediately to the effects tab to add that typical distortion effect? Not necessarily. Interesting distortion can be also achieved through the filter section, and now I want to show you one of my most favorite filter type you can get here. But at first we have to turn on the filter section and route the noise oscillator to it. And now from the list of filter types, I want to head to the miscellaneous category, and here is my most favorite Scream low pass filter. On the surface, the Scream low pass filter works just like an ordinary low pass filter, with its cutoff and resonance knobs telling how much of the high frequencies have to be removed from the noise. And now you might ask a question. Okay, the cutoff and resonance works as usual, but why is the sound that much quieter after turning on the filter? Why there is such a big volume difference? Because this filter type is waiting for you to use the drive knob. Inside of the filter, because now we are using the Scream low pass filter, we are capable of adding some distortion. So the drive knob can be used now to drive the noise into that distortion harder. So we can treat the drive knob almost as a drive knob in our typical distortion effect from Serum. What works in pair with that drive knob is the Scream one that is going to, let's say, tell the pitch of that screaming resonance and distortion we are going to add if the drive is set high enough. It's quite easy to remember. The drive tells the amount of distortion, but the Scream tells the pitch of that distortion. Of course, if we assume that the pitch of the distortion is something we can acknowledge. There is one small problem with our noise sound, and the problem is that this noise is far too simple and predictable. It's just a single, constant sound. Let's add some modulation. We have seen how much of an influence over the sound do the drive and Scream knobs have, so let's try modulating them at first. But modulating them with just an LFO is not going to give the most interesting result, because even if I add an LFO that is quite fast, that has a quite original LFO shape, despite that, the modulation is still going to be predictable. I want the noise to sound more random and unpredictable. Well, inside of the Serum we have two extra LFOs called Chaos 1 and Chaos 2. These are the LFOs that change any parameter on a random basis and basically what we can adjust is only the modulation rate. Okay, but there is no Chaos 1 and Chaos 2 tiles that I can drag towards the parameters I want to modulate. That's because these modulations can be added only from the matrix tab. So let's add these modulations, starting from the source. Our source of the modulation is the Chaos 1, the Chaos 1 LFO. And our destination is the filter, drive, and we can see that the modulation is now attached. The noise sounds much more unpredictable now. If I want to speed up this modulation to make the noise even more chaotic, I can come back to the Global tab to adjust the rate knob of the Chaos LFO. For even more random sound, I can modulate the screen parameter as well, but to have more control over the sound, I'm going to use the second Chaos LFO. For example, I might want the Chaos 2 LFO to be much slower than the first one. Now be wary. The bottom middle knob, depending on the filter type, has a different label on it. That's why, while in this filter here we can see the Scream label, in the Matrix tab this knob will be called the variable knob, because depending on the filter type, as you can see, the middle bottom knob takes a different role. On top of adjusting the LFO rates, I have 3 different switches with which I can change a bit the LFO behavior. But if we are using a high rate value, like for example in the Chaos 1 LFO, there is a high chance that these switches are not going to do anything. From what I could hear, only the BPM sync switches did something to the modulation of the noise, so use these switches in the end when everything else has been already adjusted. Alright, I've spent a few more minutes inside of Serum to tailor the noise to my beat. The settings look like that, the Matrix tab looks like that, and now let's play the synthesizer along with the synths and the kick drum. We can hear that this noise could be very interesting if it wasn't that loud. I can already turn on the utility to match the volume levels better. And we could hear that when the noise is turned on, the synthesizer we have created a few minutes earlier is drowning a bit because the noise covers that lead sound. So now, to make this noise a bit less present in the mix, at first for more rhythm I'm going to add some sidechain compression or volume automation using the LFO tool, and later we are going to use these high pass and low pass filters I mentioned in the intro of today's video to make this noise fill only the mid frequencies. At first I will work with the rhythm, because it will be easier to hear what we do with the LFO tool if the noise is not filtered. I'm going to create a standard sidechain curve. You can not only hear but see the effect of this volume modulation in the LFO tool window. On the red you have the waveform of the noise after applying the volume modulation, and on the gray in the background you have the waveform of a, let's say, dry signal. If for some reason you think that the current amount of let's say sidechain compression, but technically it's a volume modulation. It's too much. I can use this fader that works like a dry wet knob for the whole LFO tool. And in the final settings of the LFO tool, I have set the amount of volume control via LFO to 77%. What we need to do in the end is to filter out some high and low end through an equalizer. As I've said, filtering out the noise is going to give us two benefits. At first, because we will remove some of the high ends. The synthesizer we created in the first place is going to be more present in the beat. It's not going to get covered by the noise anymore. But with a high-pass filter, I'm going to get rid of all that nasty low ends that could clash and interfere with the low end coming from the kick drum, for example. Of course, in the end, this high-pass filter got set way higher, so the whole noise in general is going to sound very light. In the end, for another time, I decided to use another utility to make this noise a bit more narrow in the stereo field. To create the sad sound for our Bochka atmosphere, we will use yet another technique, yet another way of designing sounds. This time we will be stretching a sample using the PaulStretch program. I have made a tutorial on that long time ago, so if you are brave enough, you can see how I was making tutorials in the past. And in that video I have explained how to work with that plugin in a bit more accurate way. But here is a quick recap. Suppose that we have a cool snare drum sample that I would like to stretch maybe by a few hundred times to create from such a short sound something that lasts for maybe 20 or 30 seconds. So what do I want to do now? I want to find the sample on my computer. And here you will see that this snare sample is already inside of the PaulStretch program, inside of the folder where I have the PaulStretch program. But of course, if your snare drum sample or any other sound you want to stretch was in a different place in the computer, you just drag over the file into the place where you have unpacked the PaulStretch program. Alright, let's load the PaulStretch program now. That looks very old. From the file and open audio file menu. We want to find the sample we are interested in stretching. Using this file explorer is very tedious and tiresome. That's why it's very convenient to load the sample inside of the PaulStretch folder already, because if you use this option from the menu folder, by default the PaulStretch folder will be shown. So here we open the snare drum I want to extend, and with the stretch knob I tell the program how longer I want the snare drum to be. For example, I can make this sample over 3000 times longer. Of course, this would make us end up with a very long WAV file. Personally, for such a short sample, stretching the sample over 1000 times is already enough. Regardless of what you pick, if you want to export the stretched sample, you want to open the Write to File tab, hit the render selection, type the file name. For me, it's convenient to type in the file name the value by which I stretched the sample and hit render. And that exported stretched sample is something that I want to use inside of Ableton. So drag the exported file onto the arrangement view to create a new audio channel. And now you will hear that this snare drum we had in the beginning got stretched into something like that. If we zoom a bit into the waveform, you will see that the volume of this exported sound fades out. After a minute, or maybe after the 2 minutes, the sound is going to be quite inaudible. That's why I have mentioned to use a high stretch value to not bother with using either a limiter or a volume automation. For example, I can take this selection of a pad signal, of a exported snare sound, and I can loop this sound 4 times. Let me include that sound into our group of brown samples. And let's see how does this pad sound fit with the rest of the instruments. If you would like to make some tweaks to the sound, of course, we could again begin with changing the pitch of this pad sound. I can select all the 4 clips and adjust the pitch of them. Fortunately, the pad without any changes in the pitch fits quite well in my opinion, so I'm not going to change that. If so, I can already move on to using the high and low pass filter for another time, because again, this exported pad sound takes too much space in the mix. Again, from that sound I would expect only some more of the low mid frequencies. The high frequencies, I want them to be occupied most by the synthesizer here. And that's how you keep filling up the atmosphere in your Bochka or industrial techno track. We want to fine-tune the low pass and high pass filters. We want to adjust the volume of that exported pad sound. We also want to adjust its stereo width. So with this pad sound, we will be doing the exact same things we did before with the noise sound. Because these are the same effects, I'm going to just turn them on and off to show you how does the sound change. And now it's time to group all these sounds together and process them in maybe 1 or 2 different ways. At this moment, since we have already 3 different sounds, this group/parallel processing is going to be more fun than trying to add a 4th sound into our Bochka atmosphere. So all 3 sounds are going to get grouped now. And on that group, let's drop the audio effect track. Of course, the first chain is going to be the dry one, where we don't add any effects, but on the other chain, I want to add a shifter effect. With the shifter effect, I want to fill more low frequencies. So if we look into the frequency spectrum of each sound I have made so far, the pad sound doesn't fill anything below 300 Hz. Even if we turn off that high pass filter, we would get some frequencies from around 200 Hz as well, but I need my atmosphere to be a bit more heavy. So I need something that fills the frequency range roughly from even 100 Hz. So from this pad sound, we are not going to get these frequencies. What about the noise sound? In the noise sample, we had some low ends, But still, there isn't that much of the low end, plus the noise sound is sidechained. The synth sound is also empty below 400 Hz. That's why there is no need for me to use on all the sounds together a shifter effect. And now, if I use the chorus knob along with the window knob inside of the shifter effect, let's go with the pitch even lower. And now we fill the frequency area I am interested in. On top of the chorus knob, there's a window fader that controls the pitch shifting behavior. Depending on the pitch value you set with the chorus knob, you might want to keep the window size either high or low to avoid unnecessary glitching that might appear because of the pitch shift. And now it's time to process the sound coming out of the shifter effect. We are going to process the sound in the exact same way as we processed the noise and the pad sound. It's easy to hear the difference in the sound when the atmospheric sounds are soloed, but when I add the kick drum, that difference is more subtle. And that's okay, I don't need to fill much that frequency range from 100 up to 300 Hz, because at first that frequency range is already filled up a bit with the kick drum. So I can make this sound from the shifter relatively quiet. On top of everything, the sound through the shifter is also coming to the LFO tool with a slight sidechain effect. What we could do add is some more distortion. So let's add the third processing chain in the audio effect rack. And as the name suggests, in that processing chain, I'm going to add just a single distortion effect. A saturator alone is going to be enough. How do I work with the saturator? At first, I want to add quite a lot of distortion through the drive knob so I can hear what kind of distortion curve I should pick. And while, for example, the hard curve might be already too heavy for our sound because there's too much of that crackle added, the medium curve sounds kind of pleasant. So after I pick the distortion style, that's the moment where I want to tweak the drive knob to tell the amount of the distortion added. Yes, the kind of distortion I'm adding here reminds just a bit of what we have been doing inside of the Serum. The Scream low pass filter seems to give a bit similar sound of this distortion. To tweak this distortion further, if you want to fine-tune the distortion settings, you can use the color section. The color section is just a simple equalizer that precedes the distortion itself. For example, if I boost a bit the low end of the sound before passing it to the saturator, the distortion is going to be more aggressive. And we can end up with something that sounds like that. If we play everything together, we will discover that the sound coming from the saturator is a bit too, well, upfront again. It would be useful to, again, modulate the volume somehow, for example, to enhance the rhythm. That's what I'm doing with the LFO tool that is right after the saturator. Notice that the modulation curve doesn't remind of the sidechain compression anymore. This time, I'm using a totally different rhythm. This sounds pretty cool, but this sound that now reminds a bit of a plug is too loud, so here's an utility that turns down the volume of the saturator and LFO tool output. And in the end, another pair of low and high pass filters, now coupled with a single peak filter that helps making this distorted sound less annoying and hissy. If there is a need to equalize anything, it would be best to equalize the whole sound coming from all of these three chains in the audio effect track. So now that's the group processing. In that simple group processing, we have only an equalizer and a single utility. But let's see what does the equalizer do. And with the whole equalizer being turned on and off, we could hear how does the atmosphere get cleaner. Regarding the utility I have mentioned, here I tweak just a bit the volume and the stereo widths of everything. Regarding the equalization of the remaining channels, the synths channel is the only channel where we haven't been using lots of low pass and high pass filtering, so here we could find one thing or two to equalize. The most important thing to remove here would be a hollow resonance at around 800 Hz. Let's try to solo that resonance to see what we are dealing with. Such hollow sounds during mixing a track are often removed, and that's the first thing I do with the synthesizer sound here. And the remaining filters change the sound in a more subtle way. But I also use the low shelf filter and two peak filters to fine-tune the sound. So we are getting an impression of a dull sound, and this is exactly what did I want. You can see that all equalizer filters remove something from the sound. So if I want to judge more accurately, if I want to hear more accurately what does the equalizer do to the sound, I can use a bit of the gain in the end. So with this gain fader, when I turn on and off the whole equalizer, we will hear better the change in the tonality, and the difference in the volume of the synthesizer sound is not going to affect us. Maybe in the end I should have turned up the volume of this pad sound here. And now these sounds can be added to the kick drum to create a much fuller beat than what we had in the beginning.